All right, hello everyone. We are going to talk about organic nomenclature today. So, what is organic nomenclature? Well, we got to figure out what organic chemistry is. Nomenclature means naming. So, basically, we're going to be naming chemicals that are carbon compounds. So, organic chemistry refers to the chemistry of carbon. All life on this planet is revolves around the element carbon, and we're going to learn a lot about that once we get into AP biology. Carbon has 4 valence electrons. Find it on your periodic table. Look how it's got 4 valence electrons. And that allows it to bond, or it's going to make covalent bonds, and that allows it to bond with up to 4 different elements in all kinds of different ways. What we're going to be focusing on today are called hydrocarbons. And hydrocarbon means hydrogen and carbon. They're molecules that just have carbon and hydrogen in them. I'm going to show you a couple that have oxygen right now, but for the most part, we're going to be looking at hydrocarbons. So take a look at the diagram on the left here, the ring structure of the monosaccharide called glucose. So it's got all these letters and all these lines and all this stuff. Scientists don't have time to draw all that. And so we have figured out ways to draw these complicated molecules with a shorthand style. So look at the second diagram that's in blue. That's the same thing. That's glucose, but they've shorthanded it to just the ring, just that, we're going to call that a ring, the hexagon. And they indicate the one element that's not carbon with an oxygen, an O. So it says hydrogens and carbons are omitted to save time and space. So look at the diagram on the left and then look at the diagram on the right. So especially at the vertices of the hexagon, notice how each of those is a carbon, except one of them is an oxygen, and so they replaced it with an O. Now they really shorthanded this diagram by taking off I call it the flag that's on the top of glucose. So you are missing some additional stuff. So the scientists really shorthanded this, but I'm just giving you an example of what shorthand notation looks like as opposed to writing it all out, which is what we've been doing up to this point. So let's take a look and see how you guys can do shorthand notation. So first of all, every vertex, it doesn't matter whether it's a ring or a line, every vertex is a carbon unless otherwise noted. So take a look at that ring structure and how there's an oxygen, all the others would be carbons. Carbons always make 4 bonds. So let's be really careful. So when there are not enough bonds around a carbon, there must be unseen or undrawn hydrogens. So let me just give you an example. Here, actually, I'm going to do it down here. This is a better example. So every time there's an end or a point, a vertex, that's going to be a carbon. So there's a carbon here, a carbon here, a carbon here, a carbon here, and a carbon there. So there are 1, 2, 3, 4, 5 carbons in that chain right there, and they haven't shown you any of the carbons. Now, each carbon needs to bond with 4 things. So let's look at this carbon right here. That carbon is, I wonder if there's a way for me to make that the mouse. Can I do that? But oh, maybe that worked. No, it didn't work very well. But anyway, okay, so right there, that carbon is bonded to 2 other carbons, and that's what the one line to the left means and the one line to the right. So it's showing us that it has 2 bonds. Well, carbon makes 4 bonds. So where are those other 2 bonds? They're missing. Well, in the shorthand notation, those 2 other bonds are hydrogens, one that would be kind of shown above and one that would be shown below the vertex. And they're invisible. I'm not showing them to you because that's shorthand. So we don't show the carbons and we don't show the hydrogens. So what we actually have here is 5 carbons. And then here there are 2 hydrogens. Here there are 2 hydrogens. Here there are 2 hydrogens. Now, how about the ones that are at the end, the carbons at the ends? This carbon only has 1 bond shown, so it must have 3 hydrogens sticking off the end. And over here, there are 3 hydrogens sticking off the end. So if we were to count it all up, this would be C5, and then let's count all the missing hydrogens. There's 3 right here, so 3, 4, 5, 6, 7, 8, 9, and then 3 more at the bottom, 10, 11, 12. So this would be C5, did I do that right? 1, 2, 3, 4, 5, C5, H 12. Did I count it right now? No, I lost track, but you get the idea. So that's the element that we're looking at. So it says, look at the drawings to the left. Can you identify where the carbons and the hydrogens are located? pause this video if you need to. Try drawing one of the images out longhand style. So try drawing any of them, it doesn't matter, but where you've just got the lines, instead of just having an empty vertex, put a C there, put a carbon there, and then put the hydrogens that go around it. Just practice that. See if you can show the longhand version that looks like this and the shorthand version that looks like that. Are there any other elements present in all of these drawings? Are there any other elements present? Is there a nitrogen? Is there an oxygen? Is there a phosphorus? No. All you have here are what are called hydrocarbons, just carbons and hydrogens. All right, what is different about this molecule down at the bottom? See if you can figure that out. Think about it for a second. Usually students say it's that double line. Yes, what is that double line, everyone? That's a double bond. So let's think about that one for a second. The carbon that's right here at the vertex, it has 3 bonds right now, a double bond and a single bond going this way. So that must mean there's one hydrogen that we didn't draw that's actually there. So there's a hydrogen also right there. This carbon on the end, it has 2 bonds, so there must be 2 additional hydrogens at the end that haven't been drawn. It's so much faster for us to be able to write our hydrocarbons this way than to have to write every single carbon and hydrogen. All right, so let's move on. So now we're going to start naming these molecules. I will show you really quickly that back here, these were called pentanes and these were called hexanes. I should have even looked at the word and I would know how many carbons there were. Pentanes means there's 5 carbons. Hexanes means there's 6 carbons. So we're going to use prefixes and suffixes. Remember, prefixes are things that go at the front of the word, and suffixes are things that go at the end of a word. In general, a hydrocarbon is named using a prefix and a suffix joined together. The prefix represents the number of carbon atoms in the molecule. So remember, we just looked at pentane, that meant 5 carbons, or hexane, that meant 6 carbons. The suffix represents the type of bonds that join the carbon atoms. So all of them had single bonds, except for the one at the very bottom, there was a double bond. So we're going to have a suffix for that double bond. All right, now there's a video that you can watch if you look at my presentation directly. I'm going to skip that video now, but it's another way of kind of starting to master how to do this naming. And there'll be another embedded video as well. I would recommend that you write this down. These are prefixes and suffixes, and they are a little bit different than the ones that we've been using with the covalent naming. So if you have a molecule that has just 1 carbon, then it has the prefix meth. And so you might be familiar with methane. Methane, the ane suffix means it has single bonds. So methane is 1 carbon single bonded to 4 hydrogens. That's methane. Ethane would be 2 carbons bonded and all single bonds. But ethene would be 2 carbons with a double bond. So get these written down. Pause me if you want to write them down, or just listen to the video and then review, come back and write down what you think you needed to know. All right, so let's go through the prefixes quickly. Meth is 1, eth is 2, prop is 3. That's probably a new one also. Bute is 4, not but. Bute is 4. Pent, hex, hept, oct, non, and des, those ones are familiar. So those are the prefixes. Will we ever see something that's 11 or 12 or 13? No. This gets incredibly complicated super fast. So I'm only going to give you molecules that I've given you prefixes and suffixes, and then I've given you the ability to the name. I'm never going to give you something that you haven't gotten the skills yet to be able to name. Okay, and then if it's all single bonds, you're going to end the word with the suffix ane. If there is even 1 double bond, you're going to give it the suffix "-ine." And if there's even 1 triple bond, you're going to give it the suffix "-ine," Y-N-E. Now, I could make it really complicated by having some double and some triple bonds. That won't ever happen. So we're going to keep it simple just so that you get the hang of how to do this. Later on, you can learn how to do the more complicated naming. All right, so let's see if we can go through these examples. Right now, I would recommend just thinking. You could pause me at any time to see if you can come up with the names of these. Okay, so what I see are 4 carbons. Now, we wrote it out, but we didn't write the hydrogens. So notice that we could have made this exact molecule, this molecule right here that has 4 carbons, we could have drawn it like a zigzag. So the corner, the very first part is the first one. So 1, 2, 3, 4. That would be the same molecule if we were going to draw it the shorthand way. This is a little bit shorthand because it doesn't show you any of the hydrogens. So there would be 3 hydrogens around this one, 2 hydrogens around this one, 2 hydrogens around this carbon, and 3 hydrogens around that carbon, because each carbon has to bond with 4 elements. And if it's hydrogen, we're not going to show it to you. If it's anything other than hydrogen, then I'm going to draw it out. You'll see an O, or you'll see an N, or you'll see a P. But if there's nothing else there, then you can assume there are hidden hydrogens. Okay, so this first one has 4. So let's go back and take a look. What was the prefix for 4? The prefix for 4 is but. It's bute. So 4 carbons is bute, and it's all single bonds. So that is butane. So butane, you may have heard of butane. All right, the next one, let's see how many carbons. 1, 2, 3, 4, 5, 6 carbons. So let's go back and take a look. If it's got 6 carbons, it's hex. All right, and then it's got a double bond. What was the suffix for a double bond? Ene. So this one is called hexene. All right, and let's count the last one. 1, 2, 3, 4, 5, 6, 7, 8 carbons, and there's 1 triple bond. So this, what did I say? How many carbons? 1, 2, 3, 4, 5, 6, 7, 8. 8. So this is octine, Y-N-E. Octine is the name of this last molecule. All right. Hopefully you're kind of getting the hang of that. We're going to do a couple practices, and then we're going to step it up, and we're going to keep stepping it up. As you get good at it, we're going to make it a little bit more difficult. So what are the structures of decane? So how would you draw a decane? Well, I like to draw the shorthand, so I'm going to make it super fast. I'm going to make the zigzags like this. So I'm going to start with the corner is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. I just drew decane. All single bonds. Propine. Okay, what was prop? So we had meth, eth, prop. So prop is 3. So I'm going to do 1, 2, 3. That's my 3 carbons. And then one of those bonds has a triple bond. So one of them, I'm going to make it 3 lines instead of just 1 line. So I should show them. I should have shown them. There we go. So they're showing it with the carbons. So they're not doing the zigzag. It's not the full shorthand version, but still they're skipping all the hydrogens. So these are hydrocarbons. All right, so now let's start to get more complicated. What if it's not just a long chain, but what if it branches? We name the compound based on the longest continuous chain of carbon atoms. It'll make sense. Just listen. Don't even write it down right now. Just listen. Come back if you need to write it down. If there are double or triple bonded carbons, the double or triple bond must be included in the longest chain. I will not give you double and triple bonds to make the naming a little bit easier, just a teeny bit easier. We don't want it to be too easy, but just a little bit easier. Okay, continuing with these branched carbons. Any branches off of the main chain of carbon atoms are called functional groups. Just listen, we'll cover it. The names, make that go away. There we go. The names of carbon functional groups use the same prefixes, but with the YL ending. They are listed before the name of the chain. So instead of ending ain, yin, or ein, they're going to end il, YL. What? I can't even imagine what you're talking about, KJ. Here's another one of those videos you're welcome to watch, but I'm going to skip it right now. All right, so here are the branched chains. So the first thing we have to do is find the longest chain. So I go 1, 2, 3, 4, or I could go 1, 2, 3, 4, 5. Aha, 5 is the longest chain. So this is going to be a pentane. But then there is a branch right here, and that branch is called a functional group, and it has 1 carbon. So what was the prefix for 1? Do you remember? We talked about it earlier. It's one you've all heard of. That's meth. Okay, so methane is what this one would be, except we don't end it with ane, we end it with YL. So this one is called methyl pentane. So methyl tells us that there is a 1 carbon functional group, and pentane tells us there are 5 carbons in a row. All right, let's keep trying. Just listen, don't panic. We'll have lots of practice. Okay, the next molecule, I'm going to look for the longest chain. So I've got 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? That's a decane. And it's ane because there are no double or triple bonds. There's a branch right here and it goes off to the left. So this branch has 2 carbons. So what was the prefix for 2? I hope you've written it down because that really helps if you can glance at your notes. So the prefix for 2 is eth. And we say for a functional group, it ends with the YL. So this is going to be ethyl decane. Ethyl decane. All right, we're not done. It's going to keep getting a little bit trickier. All right, so let's try to imagine ethyl octane. Could you figure out how to draw ethyl octane? Pause me if you need to. Count out 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Give it a branch. I don't care where right now, but we're going to figure that out, where that branch goes, and make it an ethyl branch. An ethyl branch has 2 carbons. So put a branch and make it a carbon, make it 2 carbon branch. So there it is. Here's our octane, 1, 2, 3, 4, 5, 6, 7, 8. And here's our branch that has 2 carbons. So that is ethyl octane. All right, so how do we tell where the functional groups are supposed to be attached onto the molecule? Because maybe you put your branch over here or here or here. How are you supposed to know where that branch went? Well, you can't with the way I gave it to you. So any of those branches was legitimate. Now we're going to tell you where to put the branches. So the longest chain's carbons are numbered. The name of the group, so like ethyl or methyl or butyl, is preceded by the number of the carbon the group is branched off of. We number the carbons to get the lowest numbers on the groups. I know it's a lot of words. I don't even know that you need to write it down right now. Just listen and let's try an example. Okay, so first of all, let's number the carbons. So remember, we have to go with the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbons. So this is an octane. And I could number it 1, 2, 3, 4, 5, 6, 7, 8. Or I could start at this end and number it 1, 2, 3, 4, 5, 6, 7, 8. Which one would give me the lowest branching number? And it's if I start the counting over here 1, 2, 3. The branch is on carbon 3. If I start the counting over here 1, 2, 3, 4, 5, 6, then that's not the lowest number. So let's take a look. There's 1, 2, 3, 4. And so this is 3-methyl octane. Now, let me just make a quick comment about the use of the dash. Even though this is an incredibly precise naming procedure, there are all kinds of debates about when to put in the hyphens and when to not. So I'm here to tell you, if the hyphens help you, put them in. If the hyphens confuse you, leave them out. I'm not going to mark you wrong either way. So if you just wrote 3-methyl octane, yay, I'd give you 100% on this one. Okay, let's look at the other one. So now we could go 1, 2, 3, 4, 5, 6, 7, and the branch would be right here, and we would call that 7-methyl because it's just 1 carbon, 7-methyl octane. Or we could count it from the other direction, 1, 2, 3, 4, 5, 6, 7, 8. And instead, the name would be 2-methyl octane. Which one is right? The one that has the smaller number for the branch. So 2-methyl octane is the correct name in this circumstance. All right, let's try drawing it. 4-ethyl heptane, hept, What is that? Hex is 6, right? Hept is 7. And on the fourth carbon of this chain of 7, it's going to have an ethyl group. And ethyl, look at your notes if you can't remember, ethyl is 2. So 1, 2, 3, 4, 5, 6, 7 carbons. Now find carbon number 4. 1, 2, 3, 4, and put 4 carbons off of that. And does it matter if they go up or down? Not at all, because these are three-dimensional molecules that can rotate in space. So if you made it go up this time and made it go down the next time, it doesn't matter. It's just like you rolled it over. So it doesn't matter whether you make those 4 carbons go above or below. Oh, did I say 4 carbons? I'm sorry, I wasn't paying attention. It's on the 4th carbon. It's an ethyl group. Sorry, so it's 2 carbons. It's 2 carbons, and they can go below or they can be drawn above. And it doesn't matter, because you could just roll this molecule, and whether they'd be on the top or the bottom doesn't matter. You could even turn this molecule sideways or this way. It doesn't matter. All right, let's try 2-methyl pentane. Okay, pentane is 5. So I'm going to go 1, 2, 3, 4, 5. On the second carbon, this is the first one, 2. On the second carbon, I'm going to put a methyl group. And the methyl group, remember, is just 1 carbon. Meth means 1 in this case. All right, there's more. More numbering information. The numbering of the main chain applies to the location of the double or triple bonds as well. If more than one of the same group or bond appears in a molecule, standard covalent prefixes are used to designate the quantity of the group. What? Okay, it's okay if you're like, I don't understand this. Like, the words aren't making sense to me. It's the examples. You need to really pay attention to the examples. Then come back and look at the words and see if you can make the words make sense in your brain. So what we're talking about here is the presence of double and triple bonds. If I tell you that it's an octine, you know there's a triple bond, but where is the triple bond? So you have to give us a number of where that triple bond is. And what if there's more than one triple bond? You have to tell me where all of them are located. So that's what we're going to use the numbering system for again. And we're going to have a prefix that says how many triple bonds there are. So the numbers for the location of each group or bond are listed as well. Let's give you some examples. Okay, so let's count our carbons like we always do. 1, 2, 3, 4, 5, 6. So this is going to be a hex. And then because there's a triple bond, it's going to be a hexine. So now we need to know, where is that triple bond? We need to number the carbons. They could be 1, 2, 3, 4, 5, 6, or we could count it the other direction. 1, 2, 3, 4. It's better if we count this way. That'll give us the lower number. 1, 2. So the triple bond is off of the second carbon. It's where it starts going that direction. So we call this 2-hexine. The 2 tells us that the triple bond is located between carbons 2 and 3. The hexine tells us there's only one triple bond. If there's more than one triple bond, which you'll see in the third example, more than one double bond, we have to add another prefix. Give us a second. All right, so now we have the next example. We have a long chain. I'm going to mess around and make sure, okay, what's the absolute longest chain we can have? And I think it's the straight across one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Should I start my counting from the left, or should I start my carbon numbering, the numbering from the right? Well, if I number it from the right, then these guys are going to be off of carbons, what? 1, 2, 3, 6, 7, and 8. As opposed to being off of carbons, if I go from the left, this is carbon 1, 2, 3, and 4 are where these branches are located. Each of these branches is a methyl group. So that means that we have 3 methyl groups, and they are located off of carbons 2, 3, and 4. So how do we name that, KJ? So here you go. 2, 3, 4. That tells us which carbons are affected. And then we have to say trimethyl. Now be careful, because that prefix can be confusing. Look at the prefixes that you just wrote down. The prefix for 3 is prop, not tri. we only use the prefix. Well, okay, I'm going to say that differently. We use the prefix tri like we do for other covalent bonds. When you were naming covalent molecules, you had like trihydrogen pentabromide or something, no such thing, but whatever. That's what you had. And those are the prefix that we're going to use when there's more than one of these functional groups. But it's the new prefixes that we use to name the functional groups and to name how long the carbon chains are. All right, let's try the next one. How many carbons? 1, 2, 3, 4, 5, 6, 7. Now, which way should I count? And it turns out it doesn't matter. I could start numbering here, 1, 2, 3, or I could start numbering on the left, 1, 2, 3. Either way, this molecule flip-flops, so it doesn't matter which way I count. So the double bond starts at carbon 3 and starts at carbon 4. And it's going to end at carbon 5, but you don't have to write that. So you're just telling me where the bond starts. So it starts at carbon 3 and it starts at carbon 4. And this was a 1, 2, 3, 4, 5, 6, 7. So this is a heptene. And then you have to tell me where it was located. Here, hold on. I was trying to get my picture out of the way. I guess I can't move it. I was trying to get my image out of the way and I can't get it to move. Okay, so it's a heptene, except that there were 2 of the double bonds. So we have to call that a heptadiene. And then you need to tell me where those 2 double bonds were located. They were located off of the 3rd and 4th carbons. So 3, 4, heptadiene. What? We're going to keep practicing. Just stay calm and we'll keep going. Okay. Oops, I didn't mean for that to pop up. You got a sneak peek. What are the structures of 3-hexene? All right, that one's pretty straightforward. There's no special prefix in the middle or anything, and it's got the number 3. Hex, look at your prefixes. What was hex again? Hex is 6, so we're going to need to draw out 6 carbons. And then off of carbon 3, we're going to need to have the ending is ene. Look at your suffixes. So that means it's a double bond. Now, let me say again, pause me anytime. You could stop me right here, draw the picture, and then hit play again to see if you've done it correctly. Okay, so I'm going to show it right now. There's the 3-hexene. We've got 1, 2, 3, 4, 5, 6 carbons going across. And from the 3rd carbon, there's that double bond. And there's just one double bond. All right, here we go. 4,4 diethyl nonane. All right, let's start with the nonane. So it's going to be 9, and the ane ending means it's all single bonds. Try drawing it yourself right now without me showing it to you. Okay, so you should have 9 carbons in a row. And from the 4th carbon, what? 4, 4. Oh, that means there's one going up and there's one going down, and they're on the 4th carbon. Look at that. So notice, I wish I could move my image. I don't know why I can't move it. Notice that this one is drawn flipped. This is the 4th carbon if we start over here. 1, 2, 3, 4. Now it's the 4th carbon, and it's an ethyl because it's 2 carbons up and 2 carbons below. Now you could rotate this, you could turn it on its side, you could flip it upside down. It doesn't matter. It's a 3-dimensional molecule. But the way that we chose to draw it here is that there's one going up and there's one going down. All right, everyone, we're getting close to the end. I know that this one is pretty long. This is a long set of notes. Different functional groups. If a hydrocarbon contains different types of groups, so let's say it has a methyl and an ethyl group, the groups are listed alphabetically. Which comes first, methyl or ethyl? Well, M comes after E, so the ethyl groups have to be listed first. Prefixes, so let's say it was a diethyl. Prefixes used to show the quantity of a group are not looked at when alphabetizing different groups in a name. Actually, I'll give you a better example. Let's say, so we know that ethyl comes before methyl. But what if we had a dimethyl? So what if we had two methyl groups and it was dimethyl? We still alphabetize it by the name methyl, not dimethyl. Okay, let's try it. So let's count our carbons. Let's double check. I see a possible branch. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to try something. Or 1, 2, 3, 4, 5, 6, 7, 8. Turns out it doesn't matter. Either way, this is going to be an octane. And I say ane because it's all single bonds. Now there are two branches. I have to decide which way I'm going to count the branches, or count the carbon. So I could go 1, 2, 3, and there's a branch off of the 3. I could go 1, 2, 3. There's a branch off of this 3, 2. I will never give you one that could be reversed like this, so don't worry about that. Let's assume that we're counting from the left. So 1, 2, 3, 4, 5, 6. So now we have an ethyl group and we have a methyl group. So which one's listed first? You have to give me the numbers also. Pause me. Okay, to write this one out, it's going to be 3-ethyl. You have to put the ethyl group first. It's not about the number, it's about the alphabetizing. So 3-ethyl comes first and 6-methyl comes second. And then finally, the whole chain is an octane chain. All right. Whew. Let's try this one. Let's count our longest carbon sequence. 1, 2, 3, 4, 5, 6, 7. I think that's the same here. 1, 2, 3, 4, 5, 6, 7. So it doesn't matter. So I'm going to start counting over here. This is my carbon 1. 2 has a methyl group. 3 has an ethyl group. 4 has a second methyl group. That's like the example I gave earlier on. That would be a dimethyl, but it's still M for methyl, and a single ethyl group. So how do we name it? We're going to put the ethyl group first and its number, which is 3. Then we're going to put the 2 numbers for the dimethyl groups. We're going to put 2 numbers. And again, don't worry about where you put the hyphens. If you use them, if you don't use them, I don't care. I won't worry about it. Okay, so 3-ethyl, that's alphabetized. 2, 4, 2 and 4, dimethyl heptane is what we're working with. All right, this last one, we're at the end, everybody. I know this is a long set of notes. What is the structure of? This is just for fun to see if you can figure it out. So 5-butyl, 3,7-diethyl. You can do this. You've learned enough now that you could figure it out. Work it out with a partner. 2,8-dimethyl, 4,6-dipropyl, 1,8-non-diene. Okay, let's start all the way at the end. I'm just going to give you a tip. Well, I'll give you a few tips. So go all the way to the end. How many is our longest chain? So it's a non, so that means it's 9 carbons long. And diene means there are 2 double bonds. And those double bonds are located after carbon 1 and after carbon 8. Okay, so put 9 across. Put a double bond after the first carbon and a double bond after the 8th carbon. Now, see if you can add the 5-butyl, the 3,7-diethyl, the 2,8-dimethyl, and the 4,6-dipropyl. Now, I also want you to just take a second. It kind of is a fun drawing when you do it. You'll see it's symmetrical. It's kind of a neat picture. But notice the alphabetizing here. So the butyl group came first. It doesn't matter that diethyl had a 3. The number's not relevant. It doesn't matter. Diethyl always comes before dimethyl or dipropyl. It's the ethyl that comes first. So the B, then the E, then the M, then the P in alphabetical order. All right, pause me, draw this, work on it with a partner, and then I will release the image in 3, 2, 1. Did you get it? It's kind of cool. It's symmetrical. Were you able to solve it? All right, so we're going to stop there, everyone. We will have a practice on this. You've got some homework for tonight and then a practice on this coming up soon. Let me know if you have any questions.